All right, we're live. 11.2, 11.2. We're starting the last section that we're going to get to before the end of the 9 weeks, which is Friday, of course. Graphing square roots and cube root functions. I've already introduced you to both of these guys. Yeah. Yeah. Get a new backpack while you're at it, right? What?
No, my whole water bottle spilled in my.
Oh, it was just water.
Yeah.
Okay, I thought it was like a Coke or something.
No.
All right, go ahead. Yeah, go for it. Go for it. I said that because I thought your backpack was ruined, but it's not. All right, I have already taught you about the square root of x. So let's just kind of take a look at the square root of x in several different formats. The square root of x, this is what we call the analytic representation. The analytic, because it's got x's and y's in it, x's and y's. This, of course, is the graphical representation. And we know what that looks like too, right? It comes out of the origin vertically, and then it kind of goes off to the side. This is calculator's drawing. And then this is the numeric representation of it. So that's pretty much the three ways that we can represent a function: analytically, graphically, and numerically. And they all have to jibe with each other. Now, if you notice that the square root of 0 is 0, the square root of 1 is 1, the square root of 4 is 2, so on and so forth. We can keep going, but we don't need to. Let's go ahead and answer these questions here. They call it the vertex. Now, remember that this used to be the vertex of the parabola that gave us this version, right? We don't want those negative values, so we got rid of them. But that used to be what we called the vertex of the parabola. So because this is algebra 2 that I walked into, I'm going to go ahead and just call that a vertex as well, just like everybody else. Okay? I'll be fine with that. I have no objections to that. So what's the coordinate of the vertex? It's at 0, 0. Yeah, the 0, 0. Okay, and we put that in parentheses. Let's just go straight down. The domain in interval notation. What's the domain? Is it all real numbers? No. It's only things that are positive or 0 at the very least. So in interval notation, we would say x epsilon. We would say beefy bracket 0. What? To infinity. I'm sorry. I thought I heard a stomach grumble. Set builder. The set of all x such that x is greater than or equal to 0. There you go. This is the first time the doorbell has made it onto the recorded notes. Yeah, that was the first. You can only have first one once, you know. What's the right end behavior? As x goes to the infinity. Well, actually, let's do, are they both of them? No, they only do one of them. As x goes to infinity. So you'll drop that in there, infinity. Let's look and see what's happening. As x goes out to the right, what's happening to the y values? They're getting bigger and bigger. Not very fast, but they are going up. So guess how far up they're going to go? They're going to go infinitely high, yeah. And then for what it's worth, let's look at, is it up here? Let's look at the left end behavior. Write it in there. We'll say as x goes to negative infinity, f of x is going to where? Well, if I hop on the graph and head out to negative infinity, where am I going? No, there isn't any graph out there. I'm just wandering around in space endlessly. There is no graph out to the left. So that's why it was only asked about the right end behavior. But if I ask you, you put D and E. Y'all know what D and E stands for? Donkey nose elephant. Yeah, very good. Does? Not. Kinda. Does not exist. Does not exist. Does not eat, right? Yeah. She's thinking of a good joke, but it's hard to come up with an E noun like that makes sense. D and E doesn't exist. Or you could put none. I would accept none there as well. It doesn't have any. All right. It has a minimum, which is what? What is the minimum y value? minimum of y equals 0, and we'll go ahead and say at x equals 0. It's the left endpoint of the graph. What's the range? Well, it's going to be pretty similar. It's going to be y epsilon from beefy bracket 0 to infinity. And then set builder, the set of all y, such that y is greater than or equal to 0. The other thing I'm going to add here is no symmetry. It's neither even nor is it odd. Doesn't have either one of them. What? Yeah, I know. The x squared that generated it before we restricted the domain had y-axis symmetry. So you think this one would have x-axis symmetry, but if it did, it wouldn't be a function because it would fail the vertical line test, which is why we restricted the domain to begin with. The transformation, the standard transformation form is this. This is the same thing that we have for every single function. We have a and k on the outside, right? This is going to be this is outside. I don't want to write it all out here, but we'll just say this is vertical. Oops. This is vertical dilation. And this is vertical shift. And then on the inside, this is your horizontal dilation, HD. And then this is your horizontal shift, HS. I guess I could have used those words, but I didn't want to lose people. Yeah. Yeah, an abbreviation is only good if people still know what the abbreviation stands for. Yeah.
Would there be wouldn't the vertical dilation vary with the horizontal dilation? Like, would they be related?
They can be related, absolutely. Yeah, like a vertical compression by a factor of 9 is equivalent to a horizontal compression by a factor of 9 is equivalent to a vertical stretch by a factor of 3, because the square root of 9 is 3. So you can write one in terms of the other. Thank you, sir.
No problem.
All right, so everything that now is going to be highlighted, this is inside, and so it's affecting the graph horizontally. All right, so what does it mean to be inside a square root function? It's easy. It's the easiest one we've had. It means to be inside the radical. It's that easy. For x squared, it had to have parentheses and be inside the squared. For the reciprocal function, it had to be in the denominator, 1 over. But here, there's always going to be a radical there, and if you look on the inside of the radical, that's your inside. That's where your b and your h are found. Okay, the cube root function. Here it is analytically, cube root of x. Here it is graphically. Remember, this is really a poor depiction of it. If you want to do another one, you could actually do one like this. This is what I told you to do. Draw it like this and exaggerate it going vertical there, and then coming out and looking like that. So, but I guess this one was sketched in -10 to 10 without adjusting the window because they want you to realize how slowly it grows. It goes up forever as you go to the right, but it doesn't go up very fast. It goes up even more slowly than the square root of x goes up. But I like that version right there. In fact, I'm going to come back with a white tool and get rid of the little guy. Right? Magic. Thanks, Notability. It's just easier to label it when it's built up like that. And again, it goes vertical right there. All right, let's go ahead and fill in the blanks here. Point of symmetry. Well, you know what? They're calling this a point of symmetry right here, right in the origin. Right. It kind of looks like a hurricane now, right? It's the origin, 0, 0. You know what? I would actually be okay with calling that point a vertex still. You know what it actually is? It's not just a point of symmetry. It's actually an inflection point. Have we talked about inflection points in here? Okay, that's where the what of the graph changes.
The point of symmetry.
It's like when your voice inflects. It changes. So this is an inflection point because something changes there. And what feature about the graph changes there? Its curvature. So to the left of the origin, it's concave up like a cup, we say. Concave up like a cup. It holds water, or it's part of a smile, if you want to think about it that way. And then to the right, it's concave down like a frown. It's part of a frown. So any part of a smile is concave up. Any part of a frown is concave down. And at that inflection point, it changes from concave up to concave down. X cubed, its inverse function changed from concave down to concave up, which is the other way around. Okay, so what is the domain on this one? It says in interval notation. I will accept if you just put double bar R, even for interval notation, but, and Coach Richter asked me about this a couple of class periods ago in the passing period. Did you give credit if they just gave you the real number symbol and not an interval? And this is in pre-cal. And I'm like, yes, I did. Yes. Bless you. And that was the end of the conversation. Yeah. So then she went back and counted it right. We tried to do the same thing. Yeah. But why would I, even if it says interval notation and you put the set of all real numbers because that's what it is, I'm not going to count off because it's right. Set builder notation. Now you only get away with doing that for one of them. Okay. Set builder, you're going to have to say the set of all x such that x is an element of the real numbers. Mm-hmm. Miss Korpi? Yes. Yes, I do. Uh-huh. Okay. I'll send her in. Carly, that was for you. Your mother's here. Yeah. Yeah. If you end up watching the video because you're leaving, just go to the part where we say, bye, Carly. And yeah. Yeah. All right. Bye, Carly. Hi, Carly. That was a good show. Yeah. Did they call the last episode of iCarly Bye Carly? Because that was a missed opportunity. Yeah. All right. Bye, Carly. Left end behavior. What's the left end behavior? As we go out to the left, where is it going? It's going down, down, down. Yeah. So as we go out to the left, we're going down. And then as x goes to positive infinity, we go up. X is going to, or f of x is going to infinity. All right. What else? What else? Range. Range. What's the range of this function? Same thing. Yeah. Set of all real numbers. It's negative infinity to infinity. We should technically, if we do that, we should put y epsilon in front of it. Yeah. I forgot to do that over here. Over here on the x, just move the interval aside, put x epsilon. Yeah. That way we know it's x versus y. And then set builder would be the set of all y such that y is an element of the real numbers. All right, I wrote the right end behavior. I didn't realize it had it there. It didn't on the previous one, so just scratch this out. Scratch it out if you wrote it like I did below there. Scratch. That could be the name of your firstborn son. Scratch. Yes. What did you ask? I'm sorry. Oh, a question. Thank you.
So epsilon means element, right?
Absolutely means element of. Yeah.
So what does it mean, like in the context of these domain and range?
Oh, it just means that any value is going to work. Call it x, so long as it is in the interval from negative infinity to infinity. That's what that means.
So part of.
Yeah, as a member of the club. X is a member of the club that is contained in this
So
interval.
all x that are a member of negative infinity to infinity.
Right, they'll work. Yeah. You can also interpret this as is in. X is in that interval.
So y is in all real numbers.
Yeah. All right. Here's your standard transformation form. It's almost identical to the square root. The only difference is there's a cube root. So I'm going to let y'all just look at that. Here we go. Example 1. Identify the parent function, then describe the transformation. We got several examples here, 10 of them. If I can finish faster rather than sooner, that gives you more time in class to work on your homework. But I don't want to go too fast that you don't understand. From this section? Then what would y'all do for homework? The notes? No.
Or we just do the other.
Someday when you're a teacher, you're going to have such a wonderfully structured classroom. Oh, but you have such good ideas, is what I'm saying. No, I know you don't want to be a teacher. Neither did either one of my kids. They don't want to be a teacher. As they grow up, they said, "Mom and Dad, I don't want to live up, have my kids growing up to have a peasant's life like I did."
A peasant.
That's what they said. That's what they said. And I'm like, no, shut up and finish your bowl. Right. Yeah, porridge. That's what I meant. Yeah, that's what I imagined, a bowl of porridge. That's right.
What do your kids want to be?
Scratch.
In fact, his name is Shut Up. That's what I named him. Not Scrotch, but Shut Up. I just say, shut up, eat your porridge. Shut up, do this. Shut up, do that. Actually, his name is Tate, which is very, very close to Shut Up. Has the same number of syllables, right? Shut up. Identify the parent function and then describe the sequence of transformations. Okay. The parent function, PF. I'm going to call that PF, right? Call that PF. Let me get rid of this down a little bit. It's going to be y equals the cube root of x. Okay, easy enough. Let's describe what this is going to do. Let's do it let's enumerate it. Let's do it as bullet points. What does the negative in front do first? Which way? X-axis reflect. Just like everything else that we've done with other functions have done. X-axis reflect. Then the 1/2 is going to be a vertical compression by a factor of 2. Good. By a factor of BFO2. Then that's the last of them. So on the inside, we're going to go right 5. R5 will work. And then I didn't have room to fit it, so I'm just going to come a new column. D9. Bingo! That's some kind of weird math bingo, right? R5, D9. Bingo. RINDO. I don't know. D's nuts. No, that's a good meme. I don't know. Do y'all call that a meme if it's a video? Yeah. Okay. Yeah. It's a vine. Yeah, it was a vine originally. No, nothing cracks me up quite like a D's nuts. We're done. We're done. Yeah.
Trust double loop O's according to Wyatt.
Double loop O's?
Yes.
Okay. Noted. Write the function on number 2. Number 2. Write the function in the form blah, 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 blah. That's standard transformation form. That is vertically stretched by a factor of 4, reflected across the x-axis, translated left, and then up 3. That's kind of like what we just did, but it's in reverse, right? It's in reverse. So if it's vertically stretched by a factor of 4, is that a 4 or a 1/4? It's a 4. Good. The one inside is your horizontal stretch or compression. Yeah. It's reflected across the x-axis. Yeah, that's a negative out front, isn't it? So let me put a negative in front of the 4. Translated left 7. Is that x plus 7 or x minus 7? Plus. Very good. And then outside, we're back to normal. Up 3 means plus 3. Yeah, but that's okay, right? Better, more space than needed than fewer spaces than needed. Thank you. It's a K. Yeah, and then I can. No. I think my daughter glued it for me. Her name's not Shut Up. Her name is. What is her name again? I forget it all the time. It's pretty long. I don't think it's Jenna. I think it's called Bedazzle This for Me. I think that's her name. Yeah, everywhere I go, bedazzle this for me. She's like, what, Dad? I'm like, no. Bedazzle this for me. Number 3. That's all we had to do on number 2. I'm not kidding, folks. Is that? Yeah. Let's go to number 3. Because this is where people on the previous section, when we did it for the other functions, were like, I don't know how to do it. Write the function that's given by the graph. We have 3 pieces given to us. The first one is the vertex or the inflection point or the point of symmetry. That's what I wanted to add up here. I knew there was one thing. I wanted to add origin symmetric. Origin symmetry. Yeah, this one has rotational symmetry. Turn it upside down 180 degrees and it looks the same. Yeah. Okay, so that gives us our h and that gives us our k, right? Just as if it were a parabola that opened up or down. So let me go ahead and plug in what I know then. I know f of x is equal to the cube root of b times x minus 0 plus 2. Now, if it's x minus 0, do I really need the x minus 0 there? No, I don't. So I really get this. If you want to go straight to here, you can. It's the cube root of bx plus 2. Now we need something else, because if I'm supposed to find b, and there's currently two other unknowns in there, x and f of x, I need to know two of those three to find the third. Well, that's where I'm going to use one of the remaining ordered pairs, which I like 8-3 because it doesn't have a negative. Is that okay with y'all?
Yeah.
Okay, so here we go. New column. We'll say at 8-3 colon, at 8-3 colon. That means I'm plugging in an 8 for x and a 3 for y, 3 for f of x. What do we get? We get 3 equals the cube root of b times 8, which is 8b, and then plus 2. That's the step that a lot of people don't do. They can't get past it. Well, yeah, now we just need to solve for b. So bring 2 to the other side, so you get 3 minus 2, you get 1 equals the cube root of ab. And now how do you undo cube rooting something? You cube it. Cube it over there, cube it over here, and we get 1 equals 8b. And now I divide through by 8, and I get b equals 1/8. And then I'll just retreat back up here, and I'll say, so, what's that? Now I plug it in right over here. So I'm going to say, so, f of x ends up equaling the cube root of 1/8 x plus 2. That's kind of gross, but it is what it is. Let's talk about what the transformation that is. If you have a b equals 1/8, that's going to be a horizontal what? It's the opposite. It's a horizontal stretch now by a factor of 8. Doesn't our graph look a little bit protracted, kind of like drawn out horizontally, like someone grabbed it and yanked on the arrows? Yeah, it kind of does. Now, why did I choose the point 8.3? Would it have worked if I had chosen negative 8.1? It would have. It's just a matter of preference at that point, which one you want to use, which one you want to ignore. Yeah. Okay. See you, Honor.
What if it has? Never mind. What happened to the A?
What happened to the A? Well, they didn't give us an A option. They said to use this form right here.
Oh,
Yeah. So I started with what they gave me. But yeah, the first step is to get your H and K from your point of origin.
Why would you ever need A and B?
For this particular function,
Or like for any function with that's a cube root.
oh, you can always write A in terms of B or B in terms of A.
So you wouldn't use both, right?
You could use both. Let's say that if I use just an A instead of an A and B, the number was like 52 over 77 7,000ths. And I'm like, ugh. But if I break it up into an A and a B, it's like a 5 and a 3. Does that illustrate the point? Yeah. Why do you have different flavors of ice cream? There you go. They're all good. Yeah. It just gives you a different flavor. But some functions, the A and the B, or the A and the B do different things. You can't write one in terms of the other, like exponentials and logs. Doesn't work. So, because they actually translate into a horizontal shift. Yeah. Yeah. That's what life's about.
simple.
Simplify it down.
Simplicity.
All right. This one here, it's kind of the same, but look, we're starting with this template. A, x minus h plus k. It's the square root function. All right. This is my vertex. Well, they didn't label them for me this time. I have to find them myself. This is negative 2, 0. And then this one is negative 1, 2. The first one I use, though, is the vertex point, right? Negative 2, 0, because that's my h and k. Is it negative? It is. Why am I saying? Because no, sometimes I am. I used to not be that way, but as you get older, you get more dumber. And then when you're really old, you're the most dumbest.
Dumb and dumber.
Mm-hmm. Mm-hmm.
Never seen that.
Yes.
All right, let's plug in our h and our k. F of x equals a, which we don't know what a is yet. Square root of x minus negative 2. Ah, x minus negative 2. So that ends up being then a k of minus 1. Now, if I simplify that, yeah, if you could do that right away, that's good. Minus 1. And now I go, oh, I got a whole new column over here, way up here at the top. Let's go ahead and say at the point, negative 1, 2. And now you just carefully plug in a negative 2, for f of x, and a negative 1. So you get the a times the square root of negative 1 for x. That gives you positive 1 minus 1. This time we don't need to bring the negative 1 across first because I see that the square root of 1 is a perfect square. It's 1, so that just is a minus 1. And if I add 1 to both sides, I get 3. So what do we do with that? Now we plug that back into here.
Oh my gosh.
So f of x is 3 times the square root of x plus 2. So this technique is not something that's new to you. We've done this with the other types of functions, with quadratics, with cubics. The only difference is we have a radical function to start with. That's it. Yeah, I need the minus 1 still. Yeah, thank you. I still need the minus 1 on the outside. There we go. That'll put her there. Put her there. That's what I say every time I shake a dog's hand. All right, so far so good? Moving forward then, number 4. Identify the d and r, the domain and range of the square root function, if it's reflected across the x-axis and then translated horizontally right 8 and vertically up 3. Okay, this is fun. With notability, this is actually fun. Before notability, back in the day, this was kind of like, I wish this were fun. All right, so go ahead and draw yourself. There it is. There's your parent function. The original one. It's reflected across the x-axis. What's that going to do? That's going to make it come down like this. I'm taking it step by step here. And now I can scratch this one out. One by one. And then translated, this is where it gets fun, right? Because to translate something right 8, I can just pick it up with my lasso, come over 8 units to the right, and then up 3. I can go up 3 right there. So this would be a 3, and this right here would be an 8, and here we have the dot right there. What does that do to the domain and range? Well, it just kind of shifts it a little bit, right?
Yeah.
Big D is going to be, I like this, the set of all x such that x is greater than or equal to 8. And big R is the set of all y such that y is less than or equal to 3. There it is. Just a real quick sketch like that can give you something to look at if you label it as you go. Makes it easy. There's a lot of examples in this section. This is atypical, right? All right, any questions on number 4? The more we get through today, the more time you have tomorrow to work on the homework in class. Yeah. That doesn't mean don't ask questions. If you have a question, ask one. What is the point of symmetry? Now remember, that's a vocabulary word that they used to describe the inflection point, right? What is the point of symmetry of the cube root of x if it's vertically stretched by a factor of 2, translated left 7 and up 3? Okay, well, I'm going to go ahead and draw it vertically stretched more by a factor of 2. Okay, so here it comes. 1, there it is, vertically stretched by a factor of 2. Now I'm moving it left 7. 1, 2, 3, 4, 5, 6, 7, and up 3. 1, 2, 3. There it is. This is negative 7. This is positive 3. Could you have figured this answer out without sketching it?
Yes.
Maybe. If you know what the point of symmetry is, right? Negative 7 to the left, 3 up. It's like the same thing with the vertex of the parabola. We just follow it around. Number 6. I want y'all to do number 6 on your own, because this is getting kind of sad, me doing all these problems, and y'all just agreeing with them.
It's really like, and you cut it off.
I didn't know which one to do. It's straight.
And it's like,
All right, this is straight up in HK format, right? Yeah, so the vertex, as it's called, is at positive 5, positive 12. Yay, yay, there it is. Yay, y'all did one. That was an actual question on the notes. After all we've done, that's still a question. All right, what's the range of this function on the restricted domain? Now here this gets a little bit interesting. Let's go ahead and draw this function first of all. Negative cube root of 2x. Negative. Yeah, draw yourself kind of a light colored x cubed. It looks like that. What would a negative do to this and everything? Reflect across the what? X-axis. That makes this go up like this. And that makes this go down like this. So now, I'm going to get rid of the orange because we don't need that anymore. It looks more like that. Now, on the restricted domain, what is the, okay, so here is negative 4, and here is 1/2. Here's a half.
oh, are they both X values?
Yes. Here's 4. I want to know what these y values, whoa, these. I want to know what these y values are from x equals negative 4 to 1/2. Well, look at what we can do here. I want to know what the y value is at negative 4, and I want to know what the y value is at 1/2. So really all I'm doing is I'm plugging the endpoints that they give me into my function. So that's going to give me a negative, and then cube root of negative 4 times 2 is negative 8. And then what's the cube root of negative 8? What number types itself 3 times is a negative 8? Negative 2, yeah. And then negative 2 makes that a positive 2. So that's the upper value up there. And now I just got to do it again for the next value. What is f of 1/2? That's the negative square root of 2 times 1/2 is 1. That's going to be negative 1. And that's the value down here.
How do you know to put the 3?
Oh, I do need to put the 3 there. Sorry, it was a cube root.
How do you know?
Well, because it's this, we're using this function. Yeah. We're plugging it into that function. And now that I know the y values, I can say the range here, R, is going to be y epsilon, b if you bracket, and then you just go from least, negative 1, to greatest, 2. Chase, yeah, you can do it well. Beefy. Beefy.
I think that should be
The doorbell? Beefy. Yeah. How y'all feeling? You want to keep pushing on or?
Yeah.
I just froze.
Yeah, we can keep going. All right, let's keep going. What's the end behavior of this function? All right, let's quickly think about this function. The square root of x, that's this one here in blue. The negative is going to reflect it across the axis. The 2 is going to make it steeper. The plus 3 moves it left 3 and up 7. So the graph looks something like this. Looks something like that. So we don't have any left end behavior, so you don't even have to address it. What is the right end behavior? What? As x goes to infinity, going out to the right, your y values go down to negative infinity. Yes, ma'am, that's it. And as let's do it the other way. As x goes to negative infinity, for what it's worth, f of x equals what?
Does not exist.
That's correct. Does not exist.
Oh wow.
Yeah, make sure it's seen. You don't want someone thinking it exists when it doesn't. Yes.
Could you also use the other like arm of it and make the right end behavior unique?
What?
Couldn't you use the
For a different equation?
no?
For this equation
Because
that has this graph?
yes,
What do you want to do?
restrict restrict the arm that we didn't restrict here. You know what I mean? Like the top arm is what we use,
Oh.
right? So what if we restricted that arm?
And use the bottom one to start with?
Yeah.
You would have to make that claim before you even started, because no one thinks that that's what we call the function g of x. Yeah. So you would have to say, hey, let's start off using the other branch, negative x, as our starting value, and then everything's backwards. Yeah, we don't do that. That confuses people.
So technically this question has two answers.
No, it does not.
But there's one answer that's accepted, but there's really two.
No, because the other answer, if you assume it simultaneously, means that it's not a function, and we're dealing with functions. If you want to do it the other way, you have to specify in the beginning, and that makes it a different problem with its own unique answer.
I'm just saying though, because this doesn't say to restrict.
No, it's implied. That's why I taught it to you that way. Yeah, it's implied. There are a lot of things that are implied, right? Like when I say, sit down, you're like, who are you talking to? You implied you, right? The subject.
Oh wow, that's cool.
I mean, the question in itself though is what I'm saying
It would be a different problem if you defined it the other way, which means it wouldn't have two answers still. But could you define it differently? Sure. If you wanted, maybe there's something that'd be useful for. I've never thought of it that way. 222, make a wish.
I think I got paid like a whole lot of salary because I read some really experienced women that had relationships. They never met.
I'm going to stop here for today. And because I feel like that was a lot of information. And then going on from here, it's a little bit different. It's more of a summary and something we haven't done in a while. So we'll finish tomorrow. It won't take too long. And then you'll have the rest of the period to work on your homework.